Hi, I'll be talking about real-time transport protocols. So, real-time transport protocol in short form is called RTP. It is a type of UDP protocol being widely used on daily basis, such as internet radio, internet telephony, music on demand, video conferencing, and video on demand. So, in the RTP protocol, it's wrapped in the UDP payload, which, as you can see, this is the UDP header, and this is the RTP header, which the RTP is within the UDP payload, and it goes on and being wrapped and being sent out. So on RTP protocols, the basic function, it could be multiplexed several real-time data streams onto a single stream of UDP packets, such as multiple videos and being combined and together. It could be sent to a single destination, which is called unicasting, and could be also sent to multiple destinations, which is called multicasting. These packets are not treated specially by routers, as this is based on a UDP router. And in order to identify the packets of the RTP protocol, the RTP streams would be given a number, which the number next after the previous number would be a higher number than its predecessor. This would allow the receiver to know if there is a packet loss or not while being transmitted. So this is the RTP protocol, and the first 2-bit would be the version number, which we are currently using version 3. The P bit would be indicate that how many paddings has been padded. The P bit would indicate the packet has been padded to a multiplex of 4 bits. The X bit would be an extension header, whether present or not. CC bit would be how many contributing sources are within this packet. The M bit would be a application specific bit. It comes to when the application use it or not. And the payload type would be the encoding algorithm, letting the receiver know what algorithm is being used within this payload, and the sequence number would be the number of frames the number of frames that has been sent throughout the the RTP protocol. And the timestamp is produced by the stream source to note when the first sample in the packet was made. This value could reduce the time variable called jitter, and the contributing source identifier. If there are any used when mixer are present in the studio, this could be used to synchronize sources and streams being mixed. So let's talk about RTCP, which is called a Real-Time Transport Control Protocol, which is a sibling protocol of RTP. It's defined along RTP in RFC 3550. It handles feedbacks, synchronizations, and user interface. But this protocol doesn't transport any media samples, so this would be the contribute of what I just said is the contributing source identifier. And what does it does? It provides feedbacks on delay. Is there a delay or jitter within the packets? How's the bandwidth? Is there a congestion and other network types? With the above information from the RTCP, it could change the data rate, either increase or decrease to reduce the congestion based on the bandwidth, and to reduce the delay or jitter within it. And it handles inter-stream synchronization. So these are the this is a picture of how would RTCP and RTP works. So from the source, it would send out 1 to 8 packets. So it would send out 8 packets, and it would label as 1 to 8 to let the receiver know which packet is which, and then the packet would arrive at buffer. But as you see, there is a gap between every frame. So the the receiver would remove the packets, would wait until a certain amount of packets in the buffer in order to start playing, and so it would remove the lag between the lag or the delay, what's called, between the packets, in order to achieve smoothing a smooth stream. So this is a graph between high jitter and low jitter. So when the jitter is high, it would cause delay. When the jitter is low, and the delay would be slower. So what would prevent or fix jitter? The answer is, in order to prevent or fix jitter, is to have a better internet connection to prevent or fix the jitter problem. Thank you.